EE World, I'm Senior Technical Editor Martin Rowe. We're here at OFC, the 50th OFC. This is in San Francisco, California. This is the Ethernet Alliance booth, and David Rogers.
Currently the president and the events and conferences chair, Martin.
So, well, there you go. Okay.
I help oversee the booth, but other people are responsible for it actually coming together. So.
Okay, so why don't you show us what you've actually showing here at this booth? That's something to do with interoperability, I'm sure.
Every once in a while, we're known for doing interoperability, yes.
Okay.
So to be we have a lovely array of products demonstrating interoperability from 10 gig Ethernet up to 800 gig Ethernet. I'd say the theme of the show is 800 gig is becoming a mature product.
Is it? Where's the sweet spot at this point? Is it still at 400, 200?
It depends on who you ask. If you're asking the storage people, it's probably LR4, 100 gig, because 25 gig to a SCSI array is more than enough for a port. Okay. If you're asking hyperscalers in the AI, it's how do we get faster, quicker, better, more. So 400 gig and 800 gig are the sweet spots for the AI and the ML side of things.
So do you think next year we'll see 1.6T?
Absolutely.
Okay,
because
we're seeing it everywhere around here.
You're seeing a lot of proof of concepts, and you're seeing a lot of early adopters of the 1.6. You know, the DJ is not yet ratified, but it's coming along. The workshops at the IEEE are making that happen.
Okay.
So there's a lot of early adopters, some early silicon that we're talking to.
And that's 802.3 DJ is
yes, yes, exactly.
Okay.
802.3 DJ.
Okay. Well, why don't you show us what we've got here? If we can.
We have an array of products from our switch vendors of Cisco, Arista, and Juniper, showcasing a variety of different interconnects. Like I said, from 25 gig NRZ all the way up to 100 gig PAM4. The test sets running right now are running both LPO, linear pluggable optics, which are the low power, but still good throughput product. And we have 100 gig or 800 gig ZR Plus. We're spanning the world of interconnect with today's show.
Okay.
On the monitors, you're seeing a lot of the diagnostics and the proof of things actually operating. And if we when you get your B-roll later on, you take a look, these switches are full. There's a lot of optics that have been produced for this show, or produced by companies represented at this show. So I think the big story, or one of the bigger stories, is the co-opetition that we have in the test and measurement world. Because there's people that are specializing in different verticals in that test and measurement. We have to come together to help the end product providers do their task, which is testing and validating them.
So what kind of tests are all these test equipment companies doing?
Boy, it spans the globe from PRBS, simple bit error rate test, to test the electrical validity of the circuit, all the way up through high value protocol testing. So you have 1588 for time-based research for time-based calculations in backends of 5G networks. A lot of storage and a lot of proof of, how can we make the traffic get through faster, lower latency, higher bit rates. So we're validating from a test perspective how robust these components, switches, NICs, modules, and cables are. And the interconnect market, I think, is a big deal right now.
That's what I'm hearing a lot. There's been a lot more talk about interconnects this year than in even since last year.
Yes, absolutely.
Okay.
We've had a lot of I don't like the term, but people call it market disruptions, market disruptors. How can I take the LPO, for instance, which just ratified its specification 1.0 earlier this year? They came out and said, there's a way we can make up to 2 kilometers of data happen on an 800 gig link without using a DSP or a photonic circuit. Because of the robust strength of the Broadcom chips and the Marvell chips, the host chips, those SerDes are now more powerful than ever. So I'm going to leverage the power of that SerDes, and I'm going to go ahead and use a less powerful optic and get the throughput I need, but save energy and cost.
Very good. Thank you, David.
Martin, good to have you here. Thank you.